Hello everyone, we are the student of third year electrical. We are going to get present the CI activity of feedback control system on the topic of response analysis of servo motor. My group members are Walzade Swapnil, Deshmukh Saurabh, Bhaviskar Dipesh, Kale Ravindra. So let's start. Introduction. The purpose analyze time domain response step, that is step response, ramp response, impulse response of a second order servo motor system. Overview. In overview, we are going to get explain the define system parameter and transfer function, advantages, disadvantages and application of servo motor, then simulate response in Matlab, then model in Simulink for visualization, and summarize finding and conclusion. So system parameter and transfer function. First, what is system parameter? System parameter is a constant that influences the system response, like gain, time constant and damping ratio. This is known as system parameter. And transfer function, we know that a transfer function is a ratio of output power to the input power. So we are taking one example, that is the gain of is one natural frequency, that is which is denoted by omega n, which is equal to 10 radian per second. Then damping ratio, which is nothing but neta, which is equal to 0.5. Then transfer function, we know that the formula of transfer function is g of s is equal to k into omega n square by s square plus 2 neta omega ns plus omega n square, where k is a constant, omega n is natural frequency, then neta is damping ratio. So we put the value and we get this answer. And then we will see the advantages. In advantages, it precise control of position, speed and torque, quick response time due to feedback system, then high efficiency and reliability, stable performance even under varying load. Disadvantages: complex circuitry and control system require, then costly compared to simpler motor, then maintenance may be needed for encoder and feedbacker device, sensitive to voltage fluctuation and environmental factor. Next part will be continued by Saurabh Deshmukh. Thank you.
Model in Matlab, we have taken step response, ramp response and impulse response model. Then we have used the transfer function used in all cases, that is g of s is equal to 100 by s square plus 10s plus 100, which is a second order system function. It has natural frequency around 10 radian per second and the damping ratio is likely around 0.5. In that, we have used a step input, that is a top branch, a sudden change from 0 to 1. It is used to check how quickly and accurately the system reaches to a steady state after a sudden change in command. Then in the middle branch, we have used a ramp input. It is a steadily increasing input over time. Then we have used the impulse input on bottom branch, in which a sharp spike at t is equal to 0, that is a discrete impulse. It checks the natural response of the system. So the purpose of this model is to study and compare the behavior of the second order system under different standard inputs, to visualize dynamic characteristics like rise time, settling time, overshoot and steady state error. From this input, we have get the output graph, that is the time response of servo motor. In this output, we have get the on y-axis there is amplitude and there is x-axis there is a time in second. On the left hand side graph, the curve shows how the output behaves when a sudden step input is applied. In it, output is quickly rises to meet the input initial rise. In the overshoot, the peak goes slightly above 1, and in the settling, the system oscillates a little and then settles a steady state value, that is 1. On the right hand side, there is a ramp response graph. In that the graph shows the system's output when the input is continuously increasing ramp. The output follows the input with a small steady state error, meaning it lags slightly behind the ideal ramp time. Then we have the impulse response, in which on the y-axis there is amplitude and there x-axis there is a time, in which the amplitude is above the 5 and the time is in between 0 to 1. Conclusion. The simulation analysis of a second order servo motor system have provided valuable insight into this time domain behavior. By defining the transfer function using standard parameter gain, natural frequency and damping ratio, we observed the overshoot and settling time through step response analysis. The ramp input revealed a steady state error.
Hello everyone. I will start with the Matlab programming to analyze the servo motor response of the various inputs like steps, input, ramp, impulse using servo motor models as a second order systems. So we consider the parameters k is equal to 1, omega n is equal to 10 and neta is equal to 0.5. So k is the gain of the systems, omega n is a natural frequency, neta is a damping ratio. So the transfer functions of the systems is k into omega n square divided by s square 2 neta omega n plus omega n square. So times vectors. So time vectors is the it is a time array from 0 to 5 seconds. It skips of 0.01 for smooth plots. The step response of all time domain specifications calculate the system outputs when the unit steps inputs is applied. So delay times. So delay times is the approximate delay times as the which need to reach the 50% of the final value. Rise times, it is a times between 10 to 90% of the final values. Show peak times and overshoots. It is a formula for the peak time and overshoot, and it is a display on the command prompt. So it is a settling time. Settling times, it is a times when the system outputs enters the within the plus minus 2% of the finals value. So it is a commands to plots on the graphs. This is a plots, y lines is used to the plots on the outputs. So it is the outputs of the step response. It show the maximum value, delay times, settling times. I will show the value. So delay times is a 0.13 seconds, rise times is a 0.16 seconds, peak time 0.36 seconds, maximum overshoots is a 16.30%, settling times is 0.81 seconds. So next another one is the ramp response. So the ramp signals is the increase the linearly with the times. So here the use of the formulas and use the plots commands to the plots on the graph. So output of this, its signal increase the simultaneously with the times. So next is a input response. So impulse response is the signals of the infinite amplitudes and zero durations, but with units area under the curves. Here the use of the commands to plots to gets the outputs. So it is the outputs of the impulse response. Next simulation, Ravindra Kali.
So hello everyone, my name is Ravindra Kale, and today I will present the servo motor analysis, response analysis. So I will explain here Matlab simulation of servo motor. This simulation analysis is represented by second order transfer function. We will get a standard value to perform this simulation. So I will start with Matlab. So I will previously starting the Matlab because it is very time consuming to start. So I will start directly simulation. So in first we will require to start the blank model and go to the library browser to get the blocks. So I will get firstly step input signal, and then I will get the transfer function of a second order system, and then next I will connect it to the step input, and then we will add the scope to graphical representation of servo motor response to the input of the step. Then we will connect it, and then next I will get the ramp signal, and then get other transfer function to and connect it to the ramp signal, and next I will get the scope, and then we will connect the second order system to the scope to view the ramp response output of servo motor. And then next we will get the discrete impulse signal, and next one block adding with second order transfer function to, and I will connect it, and I will get one more scope, and I will connect it to view the graphical representation of impulse input, and then we will get another one scope to all three graphical representation in one scope. Add one scope like step, ramp and input, and then I will connect it. So then I will run it. So here we will see the graphical representation of response of servo motor. So we know that we will assume k is equal to 1, omega n is equal to 10, and neta is equal to 0.5. Neta is equal to 0.5. So we will insert in the formula to find out the value. So we know all the formula of J of S is equal to k into omega n square upon s square plus 2 neta omega n s omega into omega n square. So this standard second order representation widely used because of simplicity and approximate value. This yellow line show the graphical representation of step input. Blue lines represent the graphical representation of ramp input, and another one line show the graphical representation of impulse signal. So I will tell about the value of rise time, peak time, settling time and overshoot time we will getting from this simulation. So rise time is 0.21 second, peak time is 0.3 second, settling time is 0.23 second, and overshoot is 16.30%. So thank you.